Welcome to this very first Edpuzzle of the semester. During this unit, what we're going to do is we're going to learn about chemical reactions, and there's important things that we need to know about chemical reactions, certain parts of it that we're going to talk about today. And so this is sort of an introduction in chemical reactions, how we describe chemical reactions, and the different parts that we might see within a chemical reaction. So the first thing we're going to do is talk about the signs that a chemical reaction is occurring. And so there are 4 easily observed changes that usually indicate that a chemical reaction is occurring. And so we're going to talk about those 4 changes right now. The first change, or the first observation, is the production of heat or light. And so whenever we see the production of light or we see the production of heat, that usually indicates a chemical reaction. The next thing is the production of a gas. Now, when you boil water, there is a gas sort of being produced, but that's not the type of production of a gas. It's because that's an expected production of gas. So we expect that the water's turning into a gas. But what this is when you mix 2 chemicals together, there might be a sort of fizzing, or there might be some sort of gas being produced from there. Sometimes also you can smell that gas, and that is a indication that a gas is being produced because you can smell it, so odor change. All right. The next thing is the formation of a precipitate. Now, a precipitate in this class is usually going to be a solid that is produced when 2 solutions are mixed together, all right? And so when you mix 2 solutions together, and so these are both aqueous solutions, which means that they're 2 substances that are dissolved in water. Sometimes a chemical reaction will occur which results in a solid. And so we will mostly deal with solids as precipitates in this class. And then also a color change. So this one also we have to be careful about, because if we take like red dye and blue dye and mixed it together, that's technically, it's becoming purple, so it technically is a color change, but that's not the type of color change that we're talking about. We're talking more like if you were to burn a piece of paper or burn a log, the log might turn black, if you burn it completely, it might turn white because it becomes ash. And so those are color changes. When you bake a pizza, the pizza, starts to brown on the top, that's a color change. And so those are the type of color changes we're looking for. All right, so now we're going to talk about chemical equations. Chemical equations can be written to properly summarize any chemical reaction, and there's 3 things that you'll see in a chemical equation here. The first thing is that the equation must represent known facts and include reactants and products, and it must include all of the reactants and all of the products. Now, just a quick tip, reactants are the things that you start with, and products are the things that you produce. And so reactants you start with, products you produce, so the products are what you end with. Now, the equation must contain correct formulas. This is super important. And what an example of that is, for example, magnesium chloride is MgCl2 because magnesium is a 2+, chloride is a 1-, and to balance that, it's a 1-to-2 ratio. And so this is from last semester where we learned how to come up with formulas from the names. And so this part is actually going to be really, really important, because if you cannot come up with the correct formula, it's going to really mess up your equation later on when we try to balance it. And don't forget those diatomic elements, the Hofbrinkels, which, for example, hydrogen gas is a Hofbrinkel. That means that it's not just H, but H2. Also, the law of the conservation of mass must be satisfied, which the law of the conservation of mass is matter cannot be created nor destroyed. And so the number of atoms in each type of atom that you start with must be the number you end with. So if we start with 2 magnesium, we must end with 2 magnesium. Now, this law states that matter cannot be created nor destroyed in an ordinary chemical reaction. So again, each type of atom and the number of each type of atom we start with will be what we end with. And in a future video, we'll talk about how to balance chemical equations. Chemical reactions can be described as So chemical reaction can be described as a word or formula equation. And so a word equation, an example would be like hydrogen gas reacts with oxygen gas to produce water vapor. And so that's a word equation where I just said the words that describe what the chemical reaction is doing. Now, a formula equation is sort of your typical equation that you see, which is on the top there. So if you take a look on the top there, we have CH4 which is methane, plus 2O2, and then we have the arrow sign, which is the yield sign. Yields CO2 gas plus 2H2O gas. And so the top thing is the formula equation. The bottom one is the word, where it says 1 molecule of methane gas is added to 2 molecules of gaseous oxygen, forms 1 molecule of carbon dioxide gas and 2 molecules of water vapor. So notice how the bottom part is the word, the top part is the formula. And so again, here's another example. The top part is the word equation, and the bottom part is the formula equation. And now, within a chemical reaction, there are certain symbols that you might see within the chemical reaction. And so here are some common ones that you will see. Now, these aren't all of them, but here's some common ones. So the arrow sign means yield, and so that's between the reactants and the products. And so everything to the left of the yield sign are reactants, and everything to the right are products. And so then we have SLG and AQ, which is solid, liquid, gas, and AQ. So if you see that after a compound, a formula, that tells you what state of matter it's in. And then aqueous does mean that's dissolved in water. And then here's a couple other things. So if you have something above the yield sign, that is telling you the condition in which that chemical reaction must occur. For example, notice how the first one has the word heat above it. That means that you have to add heat to the reactants for the reactants to react together. The second one is a catalyst. So notice how there's some compound above that. A catalyst is something that facilitates the chemical reaction but is not actually part of the chemical reaction. It just initiates the process. Biology deals a lot with catalysts. And then you also have cars, which have a catalytic converter in the exhaust pipe to convert some of the dangerous gases into not so dangerous gases. And then you have that little delta sign. That little delta sign just indicates that you're adding heat. So kind of like before. And then if you, another example just to show you that's not everything. If you look on this one here, notice how for this to occur, for water to decompose into hydrogen gas and oxygen gas, notice how you have to run an electric current through it. And so that's just telling you the condition in which that chemical reaction occurs. So that's it. There's some guided practice problems in your booklet, and I have posted the key to those on the website, and so on. And so go ahead and go to those and check out the guided practice, and then try the other ones yourself. I think you'll see it's not too bad. Have a great day.